Hello friends, we usually begin the study of control systems by block diagram representation. Now why is block diagram representation important? Now any given complex system can be represented in a very easy and a simple way by using block diagram representation. Now you observe that here there is an example of a block diagram. Now each element of a practical system is usually represented as a block. Now in a block diagram representation, what are the various features you observe? Of course we see that there are blocks here, and also the transfer function of elements are written within the block. They are actually present or shown within the block. And then we also have the other elements like the summing points which compare different signals. So this is a summing point which is used to compare different signals. And then we also have the takeoff point. So the takeoff point is the signal which is taken for feedback, and we also have arrows which is used to indicate the direction of flow of signal. So any block diagram will have these features. So a block diagram will have, first of all, blocks. That's the first thing. The second thing, the transfer function of elements which is shown within the block, and then we have the summing points, and then we also have the takeoff points, and 5 we have the arrows which indicate the direction of the flow of signals. Now when we go in for a block diagram representation, we also need to know the advantages and disadvantages of such a representation, and let us see what the advantages are. So some of the most prominent advantages include that they are simple to construct, isn't it? So when you consider a complicated system, for a complicated system it is simple to construct the block diagram. So simple to construct block diagram, I'll write BD for block diagram of complicated systems. So this is one of the most important advantages. 2. The function of individual elements can be visualized from the block diagram. So what is the function of individual elements? So we can have a clear idea when we represent it in the form of block diagram. So the function of individual elements can be visualized using block diagram. 3. We can also study the individual as well as the overall performance using the transfer function shown in the block diagram. Right? So therefore we can study the individual as well as the overall performance. 4 happens to be the most important. So the overall closed loop transfer function. So the closed loop transfer function can be calculated by using block diagram reduction rules. So what are those reduction rules? We will see that in the coming few classes. So these are some of the advantages. So we can also study the individual and the overall performance using the transfer function shown in the block diagram, and we can, very important, calculate the overall closed loop transfer function by using block diagram reduction rules. Now what are those rules? How is that done? We shall see that in the coming few video sections. Now what are the disadvantages? Now given a block diagram, any block diagram does not give us any idea about the physical construction of the system. So the physical construction of the system is not revealed when you have the block diagram representation. So therefore block diagram does not include any physical, so block diagram does not include any information about the physical construction of a system. And then 2, the source of energy is generally not shown or not mentioned in the block diagram, and therefore because it is usually not mentioned, different block diagrams can be drawn depending upon the point of view of analysis. So the block diagram of a given system need not be unique. So these are some of the disadvantages of block diagram representation. Right? So now, after having gone through the advantages and disadvantages, let us see the simple or canonical form of a closed loop system considering this figure here. So let us see what these parameters are. So Rs is nothing but the Laplace of the reference input. So this is nothing but the Laplace of the reference input R of t, And then we have Cs, which is the Laplace of the controlled output C of t, which is here. C of S is the Laplace of the controlled output C of t. Es is the error. The Laplace of E of S is the Laplace of error signal E of t. Now let us see what B of S is. B of S is the Laplace of the feedback signal B of t. And what is G of S and H of S? G of S is the equivalent forward path transfer function and H of S is the equivalent feedback path transfer function. So let me mention that G of S is the equivalent forward path transfer function. So I'll write TF for transfer function, whereas H of S is the equivalent feedback path transfer function. So H of S is the equivalent feedback path transfer function. Alright. So now let us get the derivation of transfer function of a closed loop system. Right? So what is the transfer function of a closed loop system? Now let us consider B of S. Now what is B of S equal to? B of S is equal to definitely C of S into H of S. So I write B of S as C of S into H of S. And then I have C of S, which is nothing but E of S into G of S. So C of S is equal to E of S into G of S. And then I have E of S. Now what is E of S? You observe that E of S is the error, which is R of S minus plus B of S. So I have E of S equal to R of S minus plus B of S. So I call this as 1, 2 and 3. So let me put 1 in 3 for B of S. So I have E of S equals R of S minus plus, so B of S is nothing but C of S into H of S. So now what do? Let me substitute E of S in 2. So I put E of S in equation 2. So I have C of S equals E of S is nothing but R of S minus plus C of S H of S into G of S. So let me remove the brackets. So I have R of S, G of S minus plus C of S, H of S, G of S. Alright. So now what do I need? So now let me take this term to LHS, because I basically need C of S by R of S, which is the output by input. So let me take this to LHS. So I have C of S, minus plus will become plus minus C of S, H of S, G of S equal to R of S into G of S. Now from these two terms I take C of S common. I get 1 plus or minus H of S, G of S equal to R of S, G of S. So to get the transfer function, what do? I have to have output by input. So C of S by R of S. So what do I need? I need the output C of S by R of S. So I have C of S here by R of S. I get equal to G of S. And I bring this term to the denominator here. So I get 1 plus or minus H of S, G of S. So I have this expression here, right? So here I have a plus. I use a plus sign for negative feedback and I use a minus sign for positive feedback. So keep that in mind. So this is the derivation of the transfer function of a closed loop system. So I've also mentioned about the various rules which we need to keep in mind for block diagram reduction. So what are those rules? We should see that in the next video segment. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.